Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Improved ML-Based Technique for Epilepsy Detection. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed by using the artificial intelligence in the domain of healthcare, where the seizure detection technology has been developed by the proposed methodology. So before moving to this video, let's talk about that what we will cover into this video. In this video, we will initially discuss about in which application areas this developed application can be implemented in the real world, how it is beneficial. Then we will talk about what exactly the code is, what software we have used for it, and how to execute that code. Further to that, we will talk about what is the current systems those were available into it and what problem is identified into that, followed by what is given into the proposed methodology and designed in the proposed methodology to handle those issues. Finally, the experimental outcomes and findings will be discussed. So let's talk about the application area. As it is related to the healthcare, so it is very much beneficial for the biomedical applications, for the medical healthcare, and it also represents that role of the AI in the healthcare systems. So in the biomedical applications where seizure detection and many other things is not that quite easy to detect because uh, in comparison with the other problems like heart disease or any other problem, the seizure detection is quite challenging, and it is so instant because the factors those are affecting it is cannot be easily trackable, but AI can overcome these issues. So inspired from that, we are developing this system in order to detect the seizure, right? So now let's see that what exactly the code we have designed. So we will provide you the code. You will get this folder with you in which we do have this code. Along with that, we also collected the patterns for the different patients from the real-time hospitals. Those are labeled with the seizure detection, season affected people. So these are the person subjects, different subjects, those we got from the hospitals, and these are the factors those were affecting the seizure and giving you the information, the patterns, that whether the seizure will be there or not. And finally the class labels are labeled as like which stage of seizure is there. So this data set has been used and it is collected by us. Along with that, these are the files that we need to execute, and to run this code we need the MATLAB software with us. So the MATLAB software that we are using to simulate this code is MATLAB R2015B. So you can use 2015 up to 2018 because the functions those we have implemented it into it get updated after the 2018 version. So might be that is to be update for the later on version, but till now whatever the code we have designed, it is for 2015 to 2018 version. So make sure that you must have the the full version of the MATLAB instead of being the trial one. So in order to run this code, you just need to copy and paste this path here, and then you just need to paste it here, and you need to press enter. When you will press enter, you can see, for example, if I'm changing the path and here I'm pressing enter, you can see it will go to that particular folder. Here you need to run main code run file, which is here, you can see, and then you just need to see the editor window where this run command is there. I've already executed this code for you because training of the network was taking too much time and we are shorter with the time, so that's why I just already run and showed the results over here. So before running showing the further stages that what we have done, let's talk about what is the current system available. So the base paper that we were following is this, where the linear SVM and RBA method has been implemented in order to detect the seizure. So what they have done with, they have implemented, they have taken the data and then extracted the features using the RBA method, and later on using the SVM, linear SVM, in order to detect the uh, results. But their main approach was to only detect that whether it is affected or not. It is not for the multi-class, because the linear SVM is not that much capable for working with the multi-class classification. So this is basically the binary classification. So the problem that we identified is, like, in order to only detect that whether there is a seizure affected or not, it's better to detect the stage of the seizure, so that appropriate steps can be taken on time, and further health related medicines or the things can be done in order to save the patient, right? Secondly, the improvement that we had made is, like, the feature extraction is they have done with the STT, we have done with the PCA, because PCA is one of the technique, principal component analysis, which gives us the more pattern data in comparison to this. Secondly, they reduce the data. Instead of applying two different methodologies to handling the data, we have applied the PCA algorithm, which gives us the patterned information and the reduced data. Then we have applied infinite feature selection. They have not applied any of the feature selection method. They just use the feature extraction method. So feature selection is very much important, because we do have a lot of features available in the data set that might be useful or not, because the patterns must be there among the classes to identify anything. So in order to identify which particular features are best to train the network in order to get the higher accuracy, we have applied the infinite feature selection method. And finally, for the classification purpose, we have replaced the linear SVM to the multi-class SVM. So this is the code where we have done the part in which initially the data set is being read, and then pre-processing of that particular section is being done. Then feature extraction is done by applying the PCA, and after applying the PCA, whatever the feature set we got, we applied the infinite feature selection, and on the basis of the threshold weight, we have selected the features. Those were uh, greater with respect to the mean of the weight values got from the infinite feature selection. So final feature set is there. Then we have applied the multi-class SVM, in which the multiple classes data can be given to the SVM, and it train itself and gives you the outcome. So here we do have the multiple classes with us, and that gives us the information that at which stage the patient is. So let's see how many classes are there for our data. So for that, we just need to see train T unique. So it is UNIQ, unique, enter. So there are total of the 5 classes for the Caesar, right? So it gives us the outcome, and we are then comparing it with the actual test outcomes, and then calculating the parameters including accuracy, sensitivity, specificity, so that we can compare it with the base paper, because base paper is giving us the results in terms of these factors. So after getting the simulation outcomes, what we got is, let's see about the results. The results that we achieved are this. So the percentage of the proposed performance matrices in the terms of sensitivity, specificity, and accuracy is here. The values are 97.56% of accuracy, 97.79 of sensitivity, 99.39 of the specificity. Further parameters can also be extracted, because we have calculated number of parameters into it. You can see we have calculated accuracy, sensitivity, specificity, precision, recall, F1 score. But because we need to compare it with the base paper, we are just representing the 3 of the parameters out of all. But these are already calculated into it. And then we made the comparison. So in order to show the comparison, let me show you the graph. So the graphs are here. You can see we have compared our proposed methodology in terms of accuracy with PNN, double FNN, CFBNN, FMS VMM, and RBF SVM, which is in the base paper. So you can get the results from here. They have already given you the details of the sensitivity, specificity, and accuracy. And we also compared it with, in terms of specificity percentage, and then the sensitivity percentage. In every of the scenario, you can see our proposed methodology is getting higher results and showing its effectiveness in comparison to the traditional method. Further modifications are still possible because it is a very crucial area to explore, where the medical related decision is to be made by the machine. So it is required to perform number of tests and to choose the effective classifier that can detect accurately and on time, so that medicines or other practices can be done in order to save the human's life. So I hope you people like this video. For the real-time application implementation of these scenarios or for the research related work, you can contact us directly. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPax. We look forward to collaborating with you on your research journey.